Hi, I'm Michaela Livingston. I'm the head of the website for Science Brainwaves, but I've organised this year's Christmas lecture. This year's Christmas lecture is in St George's Lecture Theatre. It's an old converted church. It's fantastic, it's beautiful, holds a lot of people really comfortably and has all the mod cons to make a great lecture. After the lecture, we've got drinks, mince pies, physics experiments, all sorts, to really get people in the festive spirit and learn a bit more about physics. Science is all about the world around us, helps us understand who we are, and being able to take something that's quite mind-blowing, like quantum mechanics, and being able to put it out there to the public, it's just really interesting. And of course, if it helps inspire the next generation, that's great.
My name is Paul Stevenson and I'm a senior lecturer at the University of Surrey, and my speciality is in theoretical nuclear physics. My involvement with this Christmas lecture came about partly because I'd already been doing a lot of things a bit like this, and then one of the people at Science Brainwaves got in touch and it all went from there really. And so I wanted to talk about weird physics, some of the things like quantum mechanics and relativity and some of the surprising results that come out of that. Well, thank you very much for the kind introduction. It's indeed a pleasure to be here. I think this is my first time at the University of Sheffield, and it's a great pleasure to be in a university that has the great sense to appoint a physicist as a Vice-Chancellor. This is a fun lecture. This is a special Christmas lecture, looking at some of the things that physicists just want to look at because they're interested in the way the world works. You know, I remember when I was growing up, and my brother, who was sort of more arts inclined and I was more science inclined, he would always say to me, well, don't you think that, you know, learning all the sort of astronomy and what all that stuff actually is, big balls of gas and so on, doesn't that take a bit of the mystery and beauty out of looking at the night sky? And I think far from it. I think the reality is far more amazing and surprising than anything anyone ever came up with. And hopefully some of the things we'll see tonight are surprising and amazing things that are so weird that they're not things that people really guessed in advance. The person who is in the stationary rocket watching the person fly by really fast will see the fast-moving person actually just living in slow motion. Their clocks will be ticking slowly. They'll be moving very slowly. Everything they say, their mouth will move slowly. That's an equation from special relativity. The much less famous and more confusing looking equation, perhaps, comes from general relativity. It looks like this. And it reads G mu nu, where mu and nu are Greek letters, plus lambda, another Greek letter, mu nu, equals T mu nu. Well, what does all that mean? If you were to take the entire human population and compress them to be the same density as a neutron star, they'd be about the size of a sugar cube. So the idea is that you have an experiment where you put a cat in a box, and in that box you put a radioactive, a bit of radioactive isotope, which will just decay at random. So radioactive material decays just with a random probability, and you have a trigger set up to that so that when the radioactive decay does occur, then it releases a poison and kills the cat. But the box is sealed, and you don't know whether the cat is alive or dead. So this is where perhaps quantum mechanics and relativity could be reconciled, because we don't yet really have a theory that says those two agree with each other, and that's one of the big missing problems in physics. So if any of you younger members of the audience follow a career in physics, this could be one of the exciting things you work in, trying to reconcile two of the most impressive and most accurate theories in physics that don't currently agree with each other. So thank you very much.
Well, it's over now. Loads of people turned up despite the cold weather. The talk was really interesting, really amazing questions, mind-blowing stuff. And Paul, who was really funny, charismatic, I think people really enjoyed it, but I'd love to know what they thought.
There were a lot of very confusing moments, but I think Paul explained everything very clearly.
I thought it was brilliant and really interesting, and I learned about relativity.
The importance of these kind of events, I think, is massive, because it's a way that a diverse crowd of people, of the public, can actually come and hear science from the scientists. It makes scientists more personable. It breaks down science and scientific barriers and the complicated subjects such as quantum mechanics, which is what this lecture was on today.
I thought the lecture was really interesting and informative. I thought that Paul pitched the material at a very accessible level, both to myself and to my son who came with me. And it was really useful because I learnt something, and I also learnt enough of something to go away and do some research and explain it to my son if he had any questions for when we get home.
Oh, it's been an amazing event, and I'm just incredibly impressed by everything that's been put on here. The planning has been amazing. All this stuff afterwards with the exhibitions, the bookstall, the T-shirts and so on, really very good. It's been great fun meeting all the people up here. It's had a really good time so far. Be happy to come back.